Hello everybody. Today's video lesson is a reminder about all the details on how to calculate slope the right way, and the most important part here is that when we're calculating slope we have to have a graph to look at. Calculating the slope of a line without looking at the graph is absolutely insane, because slope, as you may or may not recall, slope is describing the steepness and direction of a line. So we need to see the line, see how steep it is, see what direction it's going, before we calculate a number which will tell us the steepness and direction. So the process, if you look at the underlines, we're supposed to graph, determine the direction of the line, positive or negative, upwards or downwards, predict the value of the slope, big number, small number, bigger than 1, near 1, closer to 0, whatever. Then we actually do the calculations. That's just like calculating average rate of change, and then we check and make sure that everything was done right. So it's an easy process, but it's also really easy to make mistakes. So allow me to illustrate how the process is supposed to look. First of all, we want to take the 2 points. In this case we have -2.5, -4, and 6, 2 1/4. And we want those 2 points to be plotted as accurately as you can, and then we draw the line that connects those 2 points. And my next observation is, what am I supposed to get out of this? So the first thing I learn is the slope is going to be a positive number. Because the line is going uphill, as we read from left to right, we're going uphill. And the second thing I know is the slope is going to be less than 1. Now the less than 1 thing is a little tricky for some. The notion here is if you had a diagonal line y equals x that is a line whose slope is 1, that forms a 45-degree angle with the x-axis. And if my line has a steepness that's smaller than 45 degrees, then I'm going to have a slope that's less steep than the slope 1. So just from looking at this picture I can see that my slope is going to be near 1, but a little bit smaller. So now I have made my predictions. Now I need to calculate slope like I always would have. And that's another thing that's going to require a little bit of thought. First I do my setup, change in y over change in x, and I have to make sure that I'm doing this right. We have the -4 subtract 2 1/4 is going to give me change in y. So it's -4 subtract 2 1/4. And from the same point, -2 1/2 subtract 6 is going to give me my change in x. Now once again, here's where the mistakes are going to be made. Some students will add instead of subtract. Some students will accidentally drop a negative. There's a number of things that could go wrong here. So before I actually get to doing my subtractions, I'm going to look at my graph and make the observation that in this case for change in y, I've got 4 below the x-axis and 2 1/4 above. So the total change in y is 4 and 2 1/4 for a 6 1/4 change. Same thing can be seen from the x perspective. If we go over 6 on the right of the y-axis, and we go back 2 1/2 to the left of the y-axis, that's 6 and 2 1/2 for a total of 8 1/2 for the change in x. So when I see my calculations here, I'm actually getting minus and minus. And when you subtract a negative, you're going to basically add the two values and make the result negative. So -4 and an additional -2 1/4 more for a grand total of 6 1/4 negative. Same thing, 8 1/4 negative, 8 1/2 negative rather. So now we have both of these are negative. Now they both become positive. So we have a positive ratio, which is what I thought I would have. But this number, 6 1/4, 8 1/2, that's a bad number. It's a fraction-y fraction is the way I call it. Now there's two ways that we can deal with this. The first is change everything to improper like they taught you in grade school. Now to explain why we multiply by the reciprocal, look at it this way. I want the denominator rather, to become 1. So I'm going to multiply it by 2 over 17. See, then the 2's divide out and the 17's divide out, and I get 1. But in order to balance this fraction, if I multiply the denominator by 2/17, I have to do the same to the numerator. 2 goes into 4 twice, and so we're going to have 2 times 17 is 34 for a grand total of 25 over 34. That's complicated, but I do see 25/34 is slightly smaller than 1 and positive, so I feel pretty good about this. But I got to check it one more way, and that is, well, first of all, I could check by taking this point and going up 25 and over 34, but that's too big. I'm going to fall off my grid. So instead I make it up 2.5 and over 3.4, that is I divide top and bottom by 10, that way I can get some numbers. So if I pick a point on my graph, like right here, and if I go up 2.5, so here's up 1, up 2, up a half, I should go over 3.4, 1, 2, 3, and some change. So I know my answer is reasonable. Everything's kind of matching what I think it should, so I can move on. Before I do, though, I want to show you an easier way to reduce 6 1/4 over 8 1/2. It's like the fraction busting techniques that we've looked at before. I'm going to use the distributive property and multiply top and bottom by 4 because 4 is the largest denominator here in common. So when I do that, 6 times 4 is 24, a quarter of 4 is 1, on the bottom 8 times 4 is 32, and a half of 4 is 2, so I get 25 over 34. Look at this, 25 over 34, 25 over 34. Here I had to do all sorts of crazy multiplying and crossing out and goofiness. Here I just used the distributive property elegantly, and there I get the result. One more quick example before I end this instructional video. We have another example where we're given the point 0.5, 1 half, 3, and 1 quarter, negative 1. Before I go any further here, I'd like us to understand our goal here, number 1, is to get better at working with fractions, so change all decimals to fractions, and number 2, to get better at arithmetic, so do not use a calculator. You can use a calculator to check your answers if you want, but do not use a calculator to get your answers, otherwise you're missing the benefit of these really, really fun exercises. So nonetheless, I plot the 2 points, I draw the line, I make my predictions. I see an increasing line, which means it'll have a positive slope. Slope is positive. And we're going to have a much bigger number than 1. That is to say, the slope is, the line is very steep. We're going up more than we go across. If we're going up more than we go across, we're going to expect a steep line and therefore a larger slope. So I know it's going to be bigger than 1 and positive. Doing my calculations, before I go any further into the simplifying, I want to point out 3 minus negative 1. What I'm trying to do there is to show that the change in y is 1 below the x-axis and 3 above for a grand total of 4. So my change in y had better be 4, which it is. And then we're going over from a quarter to a half, and that's not very far. So I had to change my scale here on the graph, as you can see, just to be able to get my line on there. So if I multiply, or rather, if I go over 1 quarter and up a 4, multiply top and bottom by 4 to get a 16 to 1 ratio. That can be observed on the graph by noticing that from this point, I pick any point on the graph, and if I go up 16 and I go over exactly 1, that works for me. That actually fits back on my line. I could also go up 8, so 5, 6, 7, 8, and then over 1 half, and that should take me there as well. 5, 6, 7, 8, and then over 1 half. Yeah, that'll work. Well, yeah, literally over 1 half. That's because it's labeled. Okay, anyway. Then you can don't forget that we could also use a context here just so we know what 16 is actually meaning. This time I use beanstalks and beans, so if we increase the number of beans, it's going to increase the number of beanstalks. This makes no sense, of course, but at least the idea is we have 16 beanstalks for every bean. These are very, very fertile magic beans. So once again, as a quick refresher, if you get 2 points and you need to find the slope, make a graph, determine the direction, up or down, predict the value of the slope, make your calculations like average rate of change, looking at the graph the whole time, and then check that your actual results match what you see on the graph. If you do that, you get slope better than any high school student in America. Thank you for watching. Have a good day.